Continuing on here, I think we're on number 5, and that is going to include, I shouldn't have done that, let's draw in blue. That's going to be deriving this guy right here, and you can see on the left hand side, that's going to require the chain rule and the quotient rule, but the outside part is that chain rule, the outside part is the square root, so that's what we're going to derive first. So for number 5, the very first part of what we're going to do here is 1/2, and then parentheses, what's inside stays the same. You do not change what's inside. And the new exponent is -1/2. That's all we did. We just derived the outside part, the square root. Inside stayed the same. Now we need to derive x over y, and that's going to require the chain rule. Not chain rule, my God, it's the quotient rule. And the quotient rule says low d high minus high d low. So low d high means the low, the bottom, y, times the derivative of the top, the high, low, d high, minus high, d low. And d low is just dy dx, all over the low squared. Cool. That is going to equal, I know I'm asking if you understand this and you're just watching this video, so you can't reply to me, but in my head I hear you say, yes, Mr. Smith, that makes perfect sense, and it makes me feel good. So, we just derived the left hand side. Now we got to derive the right hand side, and that's going to be the product rule. We have 2x times y squared. Even though the parentheses aren't there, you can imagine that they are there. And now we're going to derive the first thing, which is 2x turns into 2 times the second, y squared, plus derive the second part, derive the squared is 2y, and then you're going to have the derivative of y times the first, which is 2x. Now we need to simplify this thing. The calculus is done. We just need to simplify this guy. So, do not be afraid. You're just going to use all the rules you know. The negative exponent flips a fraction. That's the first thing I'm going to do. I'm going to rewrite this as 1/2. Negative 1/2 of this thing just turns into y over x now to the positive 1/2. This inside part stays the same. It's y minus x dy dx. All that over y squared. And that's going to be, the other side stays the same, 2y squared plus 2x and 2y make 4xy dy dx. Now, this looks super complicated because we got this fraction over here. And we don't want that fraction. And the easy way to get rid of a fraction is to multiply by what the denominator is. And really we want to multiply by the common denominator because we don't want any of these fractions. Fractions just make everything way more complicated. So you can see, since we're multiplying all these things together, the denominator, the common denominator, either way, is going to be 2 times x times y squared. Okay? Oh, I'm sorry, 2x to the 1/2, because this is inside these parentheses, it's really x to the 1/2. So I'm going to multiply by 2x to the 1/2 y squared. And what that's going to do for me is when I multiply this thing onto the left-hand side of this equation, 2 is going to kill the 1/2. X to the 1/2 is going to kill the x to the 1/2 on the bottom here, and y squared is going to kill the y squared on the bottom here. So all that's going to be left is the numerators. Y to the 1/2 times y minus x dy dx. Now, we don't consider dy dx to be a fraction. Dy dx is one variable, so just let it be. And over here, we got to multiply it, same thing times this side. So 2 times 2 is going to give us 4, x to the 1/2, and the y squared times y squared is y to the 4th. Plus 4 and 2 make 8. X to 1/2 times x is x to the 3/2. And y times y squared is y cubed. And dy dx is still there. Ain't no thing. Now, again, our goal here is to get all the dy dx's on one side, factor out, and then divide. So we can't get all the dy dx's on one side really together until we get rid of all the distributive property, I guess, that's happening over here. If you have all these parentheses and you're multiplying all this junk together, you need to distribute and then get all the dy dx's on one side. So the right hand side's fine. There is no distribution happening. It's just one big plus in the middle. Over here, though, we got to multiply this out. So it's y to the 3/2 minus xy to the 1/2 dy dx. And that's going to be 4x to the 1/2 y to the 4th. So this side's staying the same. As y cubed dy dx. Okay. Now all we need to do is move the dy, this 8x to the 3 halves y cubed dy dx over to the left side, move y to the 3 halves to the right side, factor out, and divide. I'm just going to write the answer up top here. Let me write a little small, and we'll write it in a different color too, maybe. Maybe we won't. What's happening here? I don't know if my computer can handle this or what. This is a brand new computer though, so it should be okay. There we go. Still doing the freehand. Let's write it a little bit smaller. We'll write it in red. So dy dx is going to be, on the right hand side, 4x to the 1 half y to the 4th is still going to be there. So 4x to the 1 half y to the 4th stays there. Also, I'm going to move y to the 3 halves over. I'm going to subtract it off of both sides, so it's going to be minus y to the 3 halves over. Now we're going to move this 8x to 3 halves y cubed dy dx over to this side, so it's going to be negative now. Factor out dy dx and divide by all the stuff that's there. So we're going to have, and you can do each step if you want. I'm just trying to save a little bit of time here. 8x to the 3 halves y cubed minus xy to the 1 half. And there you go. That's your answer. It's a big nasty fraction, but that is the derivative. And all this really means here, remember, don't ever forget this. If you know a point on our original graph, which is number 5 here, if we know a point that's on this curve, if we know the x and y values, when you plug it in, now we know what the slope at that point is. That's all it tells us. Okay. So let's go ahead. Let me see here. I'm going to erase all this stuff. All right. Oh, YouTube. You're not escaping this. Get out of here. All right. Let's keep going here. Number 6 doesn't look as bad as the last one, so that's good. We still got to do the chain rule, but we ain't scared of that. So we're going to drive the outside part, which is all this junk in here is being cubed. So that is the outside part. So when we first start driving, we're going to get 3. Inside part stays the same. Y squared plus x squared to the second power. And that's going to, that's the derivative of the outside. Now we need to derive the inside part. And since it's a big plus in the middle, we don't need the product or the quotient rule or any crazy stuff like that. We're just going to derive y squared separately. So that's 2y dy dx, because anytime you derive y, you got to put that there, plus 2x. And that's going to equal the derivative of 15, which is 0. Okay. Now, again, we want to get dy dx by itself. Unfortunately, we got this whole 3y squared plus x squared, which looks kind of complicated. You could, if you wanted to, multiply this into here, distribute it all and all that stuff and get everything out. But really, since this whole thing equals 0, there's nothing wrong with me dividing both sides by 3y squared plus x squared. And I'll divide by the same thing over here. Okay, and the reason we're allowed to do that is because, I mean, if it's equal to 0, then either the first big thing we're multiplying by could be 0, but that only happens when x and y are both 0, and that's not on our curve. Really, though, if you're just a first-year calc student, you're probably not even worried about that. You're just going to divide by it and be left with what's inside of here. So we could have multiplied it all out. There's nothing wrong with that, but since I'm a lazy man, I don't want to do that. And now we have dy dx is equal to negative 2x over 2y, which is just negative x over y. Okay? If you multiplied it all out, you probably have something that looks a whole lot more complicated, but it probably simplifies down to this or something very similar to it. All right. Number 7 looks absolutely ridiculous. I really regret putting it on this paper, to be honest with you. But since I did, let's go ahead and derive it. This is going to be really nasty. I'm probably not even going to simplify it, to be honest with you. Let's just go ahead and derive it. Get out of here. What is this? We don't care. Okay. So, to derive this thing, we're going to derive 2xy squared first. And that is going to give us, let's get rid of here, Product rule says derive the first part first, so again, you can think of this as 2x times y squared. And the derivative of 2x is just 2. So that's going to be 2 times y squared plus 2y dy dx times 2x. That's the derivative of the first part. Plus, now we derive the second thing. That's also the product rule. We're going to derive this guy. Deriving the first thing, 3x squared becomes 6x times y. Very good. Plus, deriving the second part is just y, so that's just dy dx times 3x squared. Okay. Minus, deriving cosine turns into negative sine, so that's going to be plus sine y, and then you derive the inside of that, which is dy dx. So that's the derivative of the left-hand side. That's really not even that bad, because there's no real distributing going on here. We can just simplify this pretty easily. And that's going to equal, over here, tangent of xy, when we derive him, derive the outside part. The derivative of tangent is secant squared. Inside stays the same. Times, now we derive the xy part. That's product rule, so derive x is 1 times y, plus derive y is dy dx times x. Plus, now we got to derive 5xy with the product rule as well. So that's going to be 5y plus dy dx times 5x. Now, to simplify all this, I'm just going to write out what the answer is here, because if you're thinking ahead, you can kind of do this in your head. Or if you have more room, you can write this all out. I know it's a big, gigantic mess, but that's okay. We're going to have everything without a dy dx on top on the right-hand side. So for right now, we're going to move 2y squared. We're going to move him over. That's negative 2y squared. This stuff is going to simplify to 4xy dy dx. 6xy also does not have a dy dx. We're going to subtract him off and move him to the right-hand side. And then minus, this has dy dx, and this has a dy dx, so we're done with that. Then on the right-hand side, the things without a dy dx are plus 5y. So we'll be here, plus 5y. And if you distribute this secant squared xy into this parentheses, you're going to have y secant squared xy. Okay, and there's a y up front you can just put there. And now everything else is a dy dx, which means we're going to move it to the right-hand side and factor out. So over here, we're going to have 4xy. That's the first dy dx. Then we're going to have plus 3x squared. And then we're going to have plus sine y. Okay, that's a plus here. All right, from the right-hand side, we'd have to move over 5x dy dx, so that would turn negative when we factor out dy dx. And we'd also have secant x squared xy times x dy dx. So we'd have minus x secant squared xy. There you go. Super big fraction. Probably a little bit more than you would ever have to do on a real calculus test. Okay, that's it.